Okay, students, so we have learned that congruent triangles, and if we go over this super quick, on congruent triangles, we can have side, 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 angles, angles, angles. And let's say that I have triangle ABC is congruent to triangle X, Y, and Z. And I already told you that order matters, order matters, order matters. AB is congruent to X, Y, and we can say that BC is congruent to YZ, and we can say that AC congruent to XZ. Also, we have said that A is congruent to X, B congruent to Y, and then C congruent to Z. So basically, we have 6 different congruency parts when you have two triangles. Well, here, basically, exactly what we're saying over here is that we have congruent parts of congruent triangles are congruent. Once you have established that two triangles are congruent, then you can say whatever you want to say about the parts that are congruent. Like that angle is congruent to that angle, or this one to that one to that other one, that line segment to that line segment, the other to the other, and so on. Okay? But you need to first say that the triangles are congruent before you say that any other part is congruent. Once you have established that the two triangles are congruent, then you can invoke Cpctc, congruent parts of congruent triangles. Corresponding parts of congruent triangles are congruent. So we take a look at this example, and I'm going to do this slowly and little by little. So what is given over here? We say that AB is congruent to DC. Checked. What else do we have? We have that angle ABC, which is this whole thing, is congruent to DCB. Checked. Okay, so we have two parts congruent. I already told you that you need how many parts? You need 3 parts. So look at this one over here. You see this? So this is reflexive. BC is congruent to BC. Okay, so now we can go slowly, little by little, and say AB is congruent to DC. Given. I can say angle ABC congruent to angle DCB. Given. I can say segment BC congruent to segment BC, reflexive. With this information is enough to prove that the two triangles are congruent. So now I can invoke that the two triangles are congruent. Now I can say triangle order matters, order matters, order matters. I'm going to say ABC congruent to triangle DCB. How? Side, angle, side. Now that I have established that the two triangles are congruent, then I can say whatever I want. I can say whatever about whatever part. So they want me to prove that A is congruent to D. A congruent to D. Yes, angle A is congruent to angle D by C. Congruent parts, congruent triangles are congruent. But I needed to establish that the two triangles are congruent first. Let's look at another example. Here we are. Okay, so we're going to take it slow. Let's begin slowly. Let's begin with that. Segment PN bisects angle M, N, O. M, N, O. This is getting bisected, therefore it's getting cut in half. So now I can say that angle MNO is congruent. Sorry, my bad. MNP is congruent to angle PNO by definition of angle bisectors. Okay? Then I'm going to go over here. MN is congruent to NO. MN congruent to NO. I'm going to go check. What is that? Given. It was given to us. Okay, what else can we say? Well, we can say that this line segment is congruent to itself, and that is right here. And what is that? Reflexive. Well, now I have three congruency marks. Look at this. We have three congruency marks. So now the two triangles are congruent. How it is that they're congruent? Side, angle, side. These two triangles are congruent by side, angle, side. After we have established that the two triangles are congruent, then order matters, order matters, order matters. Segment MP and PO. And see, so MP, OP. Yes, those are congruent. And how it is that they're congruent? By Cpctc. That's it. First. Establish that the two triangles are congruent. And after the two triangles are congruent, you can say whatever you want about whatever part that corresponds between the triangles. And now, the assignment.